Welcome back, everyone. Our next speaker for today is Marko Babić. Marko is a server engineer team lead at Wargaming. He brings 6 years of expertise in C++, Python, and AWS, and all that across global gaming projects. His talk explores the critical security measures that protect online gaming ecosystems from cheats and exploits, and all this while maintaining fast and fair gameplay. Please, give a warm welcome for Marko Babić.
Thanks. Thanks. Can you hear me? Yeah, nice, it works. So today's topic, as it says, would be Guardians of the Game. I was probably watching Marvel Marathon again when I've got the idea for the title, so that's the reason for the Guardians. But yeah, so we will explore ensuring server integrity and player safety overall. We will try to define some terms. What is the Guardian? What's the things that Guardian should think about while developing and designing a system, and also see some exploits that the players/hackers can use against our systems and are like most common to happen, and we should think mostly about them during game development. So first, a little bit about myself. Yeah, I have more than 7 years of expertise in the gaming industry. I was mostly working in Ubisoft Wargaming and some small startup in the US. I worked on Assassin's Creed games, Ghost Recon, World of Tanks Heats, and more. The more section is probably for the less likable games. so yeah. I've specialized in the backend development, live services, and player data systems. Also, I worked in a startup, so once in a while you need to touch everything else. So I can say I've also worked with the DevOps, and yeah, I've explored the music industry a little bit. But yeah, so let's start. So the opening, the role of a guardian. So as I mentioned, I will try to define what a guardian is, what are the chores of a guardian, what should he think about, and maybe some solutions that we can use to prevent our system failures during data breaches and some other stuff. So why the guardian? It's a more fancy word for a programmer. And if you work with security, you guard something. So yeah, pretty simple. So how the guardian should approach different threats? I think it's best to start with a question that we should ask ourselves. How do we protect a world where every player can be a potential threat? Yeah, so we don't, at least not completely. So because every time we patch a game or a hole in a system, a hacker finds a new one to go through it. So it's an everlasting cycle that happens all the times and that we should think about. But there's not a deterministic way that we can go with and secure that every part of the system will work safe. So the security isn't just about stopping clever people. It's also about making cheating way more effort than it's worth. And that's when the hackers will probably stop attacking you as much as usual. So, and yeah, as I mentioned at the beginning, it's hard to define a border between a player and a hacker, to be honest. Like, once you don't have any valid data to accuse someone of being a hacker, you need to consider them as a player overall. So now we will go through some different tools and threats to server integrity, and I will try to describe some corresponding defenses for them. So the most common thing that happens not only in gaming but overall are DDoS attacks. If someone doesn't know, it's like when for example, 1,000 of compromised devices overwhelm a server or a network with some fake traffic to make it slow or even unusable. So yeah, it's a really heavy. It's a really thing that it's making you, yeah. You never expect them, but you should. It's not even a question if they will happen. If you're working in the industry and you're famous, and you don't even need to be famous. You can use a data warehouse or a server host that's being attacked regularly, and even they didn't attack you, they indirectly they didn't try to attack you specifically. They indirectly attacked you, your providers. So it's not the question if it will happen. It's the question. But just when. So it usually starts with the flood piping, decreasing the bandwidth, then twisting protocols, breaking the game logic, and yeah, you don't want to come to that part because that's the moment where the players are impacted the most. So we can't stop everything, but we can make every attacker pay more CPU per packet than we do. So, and that's our win in this economic battle with the DDoS. So basically don't outblock the attackers, outlast them. So like you, oh, sorry. So like, I think like a couple of weeks ago, we had like an attack directly like in our company. And if you played like World of Tanks, you know, there are multiple different production regions, like you can pick EU1 or EU4, it doesn't matter. And during the night, they started overflooding the network on the EU4, and the players started switching to other regions just for, because they noticed lagging and stuff like that. It doesn't even matter. So during designing of the systems, we were sure that like, okay, we will always have a failsafe, the players can move on. But it's not that we didn't account. It's I will talk about more about the things that we can do to prevent it. But during entity migration between the production regions, we need to provide some data from the previous region to the new one. So in theory, they were overflooding us with false network. We started overflooding ourselves just because players started switching to new regions, and the new regions asked for more information, the attacked one. So we just overflooded ourselves doubly just because we didn't think about those issues can happen. So everything starts from the internet overall, the Wild West. So imagine like 50,000 fake accounts suddenly decide to play your game, and that's our new player base. So the first place on that's on Impact, it's the Edge CDN, and that's the first shield where we should try to that's the first shield. So when we are being hit, for example, 2 million requests per second, the CDN should say, okay, nice try, and give them a 403 error instead. So next, the load balancer. So we should spread the load, but as I mentioned before, it's not always the best. It's not always the only solution applicable for this case. So we should prevent one region from melting while others not. So then stateless gateways, classic verified tokens, sessions, sanity check requests before hitting game logic. And then the fun part, the game servers. So yeah, this is where the fun happens. And to be honest, it should never get to this point. So something is wrong if they manage to come to our servers and disturb the game logic. And the subsection of the game servers are also subsystems that we can use to detect, prevent, and so databases for handling states, matchmaking, for building fair sessions, and telemetry overall to see if something happening wrong in our ecosystem of the servers. So yeah, what would be the conclusion? So drop the noise early and don't let the garbage reach the logic, because then the fun is compromised. So yeah, next thing would be cheating tools, and probably If you didn't, you heard about the cheat engine overall. So, and the most common thing is client tampering, like in DLL injections, memory edits. So, for example, progression manipulation, experience manipulation, and stuff like that. Sometimes that could be fun. You know, if you're making a game that's not only online and you don't want to control the players that much, but if you're working in a AAA industry where every data is important, and uh, uh, yeah, you need to think about this kind of stuff. And as I love saying, you should never trust the client during game development. So you should try to make predictions and everything server side. Packet manipulation, so classical man-in-the-middle attacks, data spoofing, so representing as another person. That's a classical thing. So man-in-the-middle proxying can also rewrite payloads between the server and the client. So that can be a risky thing for accessing data that they shouldn't. Speed and physics hacks is like a subsection of client tampering, but in competitive gaming, it's a separate topic and really important. Just because, I mean, imagine play CS and then someone just spawns in front of you and kill you if you don't have any reliable checks to prevent that kind of stuff happening. And casual gaming nightmare botting, like automated scripts for non-stop playing, like farming experience during gameplay, like you're trying to, like example, last week I was playing Battlefield and two guys were camping inside of the tanks the whole game, so just to farm experience, and that's that. So you need to have some systems to help you prevent that kind of stuff. So yeah, try when you think about client tampering and stuff like that, try to make it fun when you want to respond to a hacker or a player. Maybe sometimes player want a more challenge and make the game harder. If you know, like if they detect you cheating, then the game becomes like 10 times more harder. So it's about the challenge. So it really depends on what type and what do you want to achieve in the end with protection and security. So try to diminish their success, but try to make it fun. So some of the stuff that that is helpful against the client manipulation and stuff like that. As I mentioned, we should never trust the client, so we should always verify data on the server side. Stateless edge authentication, as we mentioned, like short-lived session tokens, bind session to client attributes, so fingerprinting everything, speed and physics hacks. So we should have movement prediction also on the server side, but we also need to include some part of latency issues that can happen on the networking layer. So sometimes not the stuff you see on the screen is not the stuff that's happening on the server side. So you need to be aware of that stuff. For botting, so that's anomaly detection. That's collecting and analyzing data overall. With each patch, we can have like a new opportunity for misusing the game logic and, as I mentioned, like farming experience and stuff like that. So you should collect data, analyze data, and with each new information, like try to focus to optimize and prevent that kind of stuff happening. And one of the fun stuff that's usually like likable and used in gamings are random challenges, not only in gaming but in APIs overall. Try to force the client to use their hardware to calculate some stuff just to be sure if they are really using their hardware resources, and it's not just a proxy that reflects the data to our server. So it's not like if someone uses their device and has a client running that's manipulating, this will probably fail because they would know what to calculate and then they will give the correct answer. But for example, calculate a hash function of a random number that's sent, you need to invest some hardware data that's going to probably accumulate over time, and that's going to slow down the system that's attacking you at that moment. So, and yeah, after cheating tools and client manipulations, the most common and most nerve-wracking thing for the players are data breaches. So everything starts with something simple, credential stuffing from old password dumps, lazy SQL injections, remote client executions in the APIs, and somehow a lost credential of some development staging got into the hands of a person that it shouldn't. So with the stolen credentials, then we start with moving across environments. It comes from the staging, then some in between, like then from the stagings they can easily, and developments environments, they can easily go to production ones. Then they can access our ecosystem CI/CDs. Like I even saw once in a live CI job on Jenkins, a guy putting like a live AWS key for S3 access. So yeah, imagine that coming to a person somehow. There's a lot of ways to get that data out, like DNS tunneling and hiding the data in HTTPS traffic. It's really hard and to detect. And so what comes from this is account takeovers, identity theft, in-game economy abuse, and that affects your value on the market overall. So we have some stuff that's helping us to prevent that kind of issues. But the most common thing that we rely on now these days is zero trust architecture. So the core principle of it is never trust, always verify. So instead of relying that some devices are on the same network, always verify that some kind of tokens and stuff like that, just because you should never trust the source of information that's coming from you. Classical database encryption overall. Secret rotations, static secrets are fossil, as I mentioned. So yeah, try to rotate those secrets all the time, just to prevent a leakage of that kind of stuff. And yeah, system call monitoring and integrity checks is an important thing of this. But yeah, I believe that we can have just a panel about these topics overall. But yeah, so I wanted to talk about technical solutions and stuff that we can use overall in gaming. But then I decided maybe it's a better thing to discuss like one interesting thing that I've started using in the company, and that's useful maybe during development. So I don't know if you heard about port knocking overall. It looks like something like this. Sorry, I mean it's Halloween today, so yeah. So how it works. So the thing is, so it's prevent unauthorized SSH or APIs access by requiring the client to perform a specific sequence of accessing port attempts before the actual port is even available. So everything starts with the default. For example, let's use SSH. Everything starts with all the ports closed, and the firewall prevents any access for any type of accounts that try to connect to that port. Then the client sends the connection attempts, the knocks, in a predefined port sequence, and that's the place where you can play the most. So before requiring the client to access to a specific port for using SSH, you need them to try to access different ports on the system, for example, so you can verify their integrity. So we have like a small daemon on the server that monitors those packets. And when the correct sequence from an authorized source is detected, the firewall opens for a short time for that specific account or a user to access to establish a connection using SSH. So what are the benefits of this? It's an invisible entrance, so it looks like it's not accessible overall if you don't know where to look. It's a short-lived connection, so it's a limited one-time access, so this sequence can change every time, and we can require like different calculation on the client. For example, the challenge, we can request a hash of different values just for us to get the sequence of the ports that we can use on the system. Yeah, each sequence can be unique per user, so that's one of the most important things as well. And yeah, so there's an improvement to this whole solution, the single packet authorization. So it's without using all the handshakes and stuff like that, instead using like a one UDP packet with additional and secure information, so you can start the connection right away. So I wanted to also to give an example how we use it in the company for like in the matchmaker when we want to decide who to matchmake with, what's the best data region to connect and stuff like that. So sometimes you want to ping on a server, for example, or a data center just to be sure how fast the connection is, especially in competitive gaming. And while you want to ping a server, you don't want to spam it overall. So before establishing the connection and started the ping, we can request a player to do a port knock from time to time, so we can restrict the time he has to establish his call. We can randomize the calls, spread them, load balance them over time, so not to overwhelm our server. But it's a really useful tool that can be used in different kind of stuff. So in pinging, detecting the latency, and then with the latency, we can use that information in the matchmaker, so we can connect players based on that. So for one example, let's name the Bastion as a jump server, something in the middle. We can use port knocking with Bastion as a proxy, so establishing the connection with the Bastion. The Bastion itself, so with the port knocking mechanism, the Bastion itself initially is a new SSH connection to the production server, and then we use that connection through the proxy and never connect the client to the production server. And this is a thing that's now used mostly because you never trust the client, as I mentioned before. So, and all the data can go through the server and then to the production one. So you can use the Bastion to verify the stuff that we mentioned, filter DDoS attacks, client tampering, prediction, and stuff like that. So depends how you much spend time on it. And then like classical certificate forwarding. So you connect with the Bastion, with the SSH, you provide the certificate, that certificate is validated, the Bastion forwards the client's authentication request to the production verifies it, and then the Bastion just bypass your connection from the client directly to the production server and use it. It was used some time ago, but now when data is really important and need to be verified, the first approach is mostly being used. So now comes to the, I love calling it conditionally speaking like the philosophic part of the presentation and how to balance everything that we mentioned before. So this is the eternal triangle, and the toughest part of the Guardian is the balance between them. So every time we add a security, increase security, we risk adding friction to our system. So every shield that we add adds a little bit weight to the system, and that affects the speed. So every time we optimize the speed, we risk opening a hole, and that's the relation between the speed and the security. And then the most important part for the gamers overall is fun. And every time we prioritize fun, we affect both of them by adding new features that require new systems for security, and then can also speed down the whole system and affect the performance of the ecosystem overall. So this triangle lives in every system that we design, and it's never perfectly stable. So it's always leaning to some angle of the triangle, and it really can depend on the mood of the day or of the features that you work on. But during initial development, you need to think about it and try to figure out what works best for you. If you're in competitive gaming, security will be important. If you don't plan to use any online systems, then fun is the only thing that you need in a relationship with the speed. So let's imagine a situation where our team got serious about validation, and every package had to be checked, verified, signed, time-stamped before it was even looked at the server. So in theory, it looks perfect for competitive stuff, or I don't know, like for security reasons, data progression, and inventory management. But it only looks like that on paper, because what comes with strict validation is low latency and low latency problems. So on paper, it was flawless, but in practice, a player in low latency region started the rubber banding. So basically, our system started DDoSing the players themselves unintentionally. So yeah, security worked in this case, but gameplay didn't. It failed, just because the user's fun experience was manipulated and changed. So a perfect wall is useless if no one wants to play inside it. So yeah, as I mentioned, this is the philosophic part, and this is where everyone should try to balance the stuff that they work on and the system they design, just to prevent this kind of issues happening. So player expect instant actions, so matchmaking, shooting, trading, and if every one of those goes through 10 layers of validation, your security just become your bottleneck, as we mentioned on the previous slide. So in these days, probabilistic checks using AI and MLs, you can determine where the impact in what part of the project or our infrastructure is most impact for player engagement, and based on those probabilistics and calculations, we can prioritize the risks and try to balance our solutions and focus more security in that spots that are more riskier for player engagement and not for us. And one of the most useful things are post-match audits. So try not to create the cheaters in real time, not to use your resources during playtime and lose the speed there, but you can always do it after. So review patterns, detect cheaters, and instead of slowing down everyone in the moment. So, and the art of keeping it fun, security is security is invisible when done right. So when gameplay feels fair and smooth, that's the mastery. That's the thing that we should keep in our mind all the time. So like game balance itself, you don't just launch once and walk away from your system and your project. You should always like adapt to how players behave and how attackers evolve. So yeah, protecting fun, not losing speed, and maintaining security on an appropriate level. So trying to find the balanced formula. I mean, as every scientist or a person that comes to science tries to find a way to define a formula that works in every solution, and this is just like my simple simple vision of this whole system. So yeah, integrity is a combination of three of different angles of that triangle. So security is in its core, but the speed and the fun gives the integrity the most meaning. So if you lose speed, you'll lose the whole integrity overall, because the player doesn't even want to know is it secured. They always they are always in a mood. It should be secured by default from the moment one. If you lose fun, then you don't have players. You don't have what to protect overall. So you should think responsibly when trying to balance it. And to try to summarize everything that I talked about in this presentation. As I mentioned at the beginning, I try to define the role of the guardian and what the point of the guardian is overall, and what should we think during game development. Is designing systems, assuming they will be attacked. We need to adapt constantly, so threats evolve, so our security should evolve. It's a multi-team discipline, so talk with your DevOps, with your monitoring, or I don't know, engage with your team when trying to set up architectures for this kind of systems. Fight cheater smartly, so let your defense evolve by understanding your attacker's creativity. Observe everything, collect data, as we mentioned. Scale responsibly, so more servers doesn't always mean safer servers. Player comes for fun, so keep it fun overall. And performance graphs are great, but player trust is the final goal. And what's the connection of it all is us, the guardians. So yeah, to finalize everything and ask ourselves a question. So if we guard the whole system, who guards the guardians? And the answer comes pretty simple. We do overall. Because protecting the game isn't just about stopping the bad guys. It's about never stopping ourselves from improving how we protect those systems. And yeah, that will be it.
Thank you, Marko. I think we'll have time for one question if there's one. We have one here. Just a second for our volunteers to bring the microphone.
Hello.
Hey.
Have you thought about giving players an ability to complain about cheaters real time?
Yeah, of course, but it's hard to distinguish. How many times have you played a competitive game and you assumed you were cheated, but it was just you lacking skills, for example? I don't know. I mean, it's more on the data analysis that comes from your request to find to verify if someone is a cheater, but it's hard. I think we in the company we have a team that's going on like through those requests and needs to analyze data that was happening at the time that you were submitted your appeal or the game or the session, and try to figure out what is happening so you can understand if someone is a cheater or not. So it
exists already. You have it.
Yeah.
Yeah. Okay. Because I know in Telegram it works like this. It protects from spam when you complain about spam request, and it goes somewhere. It's aggregated, and it works really well. So I don't have a lot of spam in Telegram.
Yeah, so I don't know. I didn't spend so much time. That those kind of requests never comes to the engineer in the end. It always goes to data analysis and stuff like that. So yeah. But I believe, I mean, it's always always need in online type of games to have a system to prevent that kind of manipulation and report players overall. So yeah.
Thank you.
No worries.
That's it. Unfortunately, we ran out of time. Thank you, Marko, once again.
Thanks.